Right. The diagram shows the speed time graph for train journey between two points. Find the acceleration of the train during the first 40 seconds. So acceleration is change in distance over time. Okay. Sorry, change in speed over time. Or you can say it is the gradient of the speed time graph. Okay. So you can find the gradient of this first part. Okay. Gradient is equal to rise over run 12 over 40. Or you can use the other formula also. This point is 40 12. This point is 0 0. So you can do m2 minus y2 minus y1 over x2 minus x1 also. 12 minus 0. Sorry, y is 12. Yes. 12 minus 0 over 40 minus 0 is 3 over 10, 0.3 meter per second square. Next, I hope it's clear. Next, calculate the distance between the two stations. Distance from the speed time graph. Okay. Distance is area under the curve. Okay. Because distance is equal to speed multiplied by time. And when we are finding area, we are actually multiplying speed with time. So let's divide this into three parts. This is A, let's say this is B, this is C. So A is a triangle, okay, 1 by 2 times 40 times 12. Two 40 meter. Let's find B. B is a rectangle, so 250 minus 40 times 12. 2520. And C is again a triangle. Base is 300 minus 250. And height is 12. So this is 300. Now we can just add them, okay? 240 plus 2520 plus 300. 3060 meter, okay? Any questions, any doubt, please tell me before we move on.
No, sir.
Okay. Let's move on. We have any other part? No, we don't. Okay, let's start. All right, car starts from rest. Again, we have a speed time graph. Car starts from rest and accelerate at 3 meter per second square. So first of all, for 4 seconds, 3 meter per second square. That means this line, the gradient is 3. Okay. So speed time graph gradient gives us the acceleration. The car then travels at constant speed for 10 seconds. We can see that. Okay. Find the value of V. So since the gradient is given, what's the coordinates of this point? Let's say 4 and V. Okay. and this is obviously origin 0, 0. So we can find, we have the gradient, we can just apply the formula to find V. Okay. The second, some students can't join the meeting. All of you have joined. Yes, Hussain, Atik, you were saying later you can't join. Now you are already in the class. Okay. Any question, anything unclear, Hussain, please tell me. Okay. Okay. So we can just apply the formula y2 minus y1 over x2 minus x. So v over 4 is equal to 3. So v is equal to 12. What's the unit? Meter per second. Right? Because gradient is 3, acceleration is gradient. Calculate the total distance traveled. Okay. So previous part, we know that it's area under the graph. Okay. There are two methods. Previously, in the previous question, we divided into a triangle and a rectangle. Okay. There is one more method. I'm sure you know that. You can use the trapezium also. Isn't it a trapezium? This whole shape. So this time, let's use the trapezium formula. Trapezium is area of trapezium 1 by 2 into height into sum of parallel sides. Okay. So height is between the parallel side. This is one parallel side, this is the other. Height is obviously V, which is 12. Okay. Parallel sides, one parallel side is 14 and the other is 14 minus 4, 10. Okay. So it's 144 meter. Okay. If any problem, please tell me.
So could you explain which formula you have used in part A?
Part A. Part A is acceleration. Okay. From physics, you might have learned acceleration is change in speed over time. Okay. Speed or velocity over time. Okay. So if you have a speed time graph, okay, let's say you have speed here on the y-axis and time on the x-axis. Okay, this is the line. So when you are finding the gradient, okay, when you are finding the gradient, you are basically dividing rise over run. So basically speed with time. Okay. When you are finding the gradient, you are actually finding change in speed over time. Okay. So we can say that gradient of speed time graph gives acceleration. Is it clear? Can we move on?
Oh, yes, sir.
All right. So distance is 144 meter, but you can also do it in the other way. You can just find the area of the triangle first. That is, triangle will be 1 by 2 time base is 4 times height is V. V was 12. That is 24. And the rectangle area, is 14 minus 410, length into width, times V, 12, it's 120. So again, 120 plus 24 is 144. Okay. Any questions? Please tell me. Let's move on then. No questions.
No, sir.
All right. So these are all P2 questions. Okay. Once we're done with P2, we can do P4 also. Now we have to plot a distance time graph. Okay. How to pronounce this name? Annette. Annette cycles. Annette cycles a distance of 70 kilometer. Okay. From this town to this town. Leaving mid-valley, she cycles for 1 hour 30 minutes at a constant speed of 20 kilometer per hour, and then stops for 30 minutes. She then continues the journey at this. So draw this distance time graph. Okay. I'm sure you can do it. First of all, 1 hour 30 minutes. Okay, so 1 hour 30 minutes is this point, right? 1 hour 30 minutes. Constant speed of 20 kilometer per hour. Okay. Now, the gradient of distance time graph gives us speed. Okay. A lot of physics here. Gives speed. Okay, because speed is equal to distance over time. So if we are finding the gradient of distance over time, we are dividing distance with time. So that is speed. Okay, now they say constant speed of 20 kilometer per hour. Okay, so that means a constant gradient. Okay, it's a straight line. Okay, constant gradient of 20 kilometer per hour. Okay, so let's find the distance she travels in 1 hour 30 minutes. Okay, first of all, distance is equal to speed multiplied by time. Okay. Wait, let's find the gradient. That's better. 20 will be distance over time, and time is 1 hour 30 minutes. Okay, so distance will be 1.5. 70 kilometers. Eyes overrun. 30 kilometer. Okay, 20 times 1.5. Okay, 20 kilometer per hour times 1.5 hours is 30 kilometer. Okay, so we have got a point here. At 1.5, you can put a dot at 30 kilometer, half of that. This is 30. So let's go here. Okay, 30 kilometer. It's a straight line. So let's just join a straight line. After that, and then she stops for 30 minutes. So no more distance for the next 30 minutes. Okay, for the next 30 minutes, that means until 2 hours, it's going to be a horizontal line. She's not moving. Okay, So it's stayed at 30. She then continues the journey to Newton at a constant speed of 16 kilometers per hour. Okay. He has to reach 70. Okay. It's a bit long question. This is 70 kilometer per hour. Okay. Where should we match it? Starting from here, she needs to reach there. How much distance is remaining? 70 minus 30. 40 kilometer is still remaining. Okay. She's traveling at 16 kilometer per hour. Speed is equal to distance over time. Speed is 16. Distance is 40. How much time will she take? 40 by 16. It's 2.5 hours. Okay. So from these 2 hours, you can add 2.5 hours. 2.5 plus 2 is 4.5. And at 4.5, she is going to reach the 70 kilometer mark. Okay. Let's join that. Okay. Here the gradient is 16 kilometer per hour. And the earlier one was 20 kilometer per hour. Okay. It's a 3-mark question. That's why a bit long working. Okay. Next is calculate the average speed for the whole journey. Average speed is total distance over total time. Okay. So total distance is 70. Total distance is 70 and total time is 4.5 hours. Okay. So this is 15.6 kilometer per hour. I think it's finished this question. Please tell me any doubt here, any part unclear. You can ask question.
No, sir.
Hussain, Ateek, Safi, Shavez. Okay. Let's continue then. Okay. Abdul draws the speed time graph. Okay. Complete the statement about the speed time graph. Okay. Okay, which section cannot be correct? Please tell me.
D.
Yes, D. Why? What's the reason here? Because he moved back in
The
time.
time can't go reverse.
Yes, but why? Because he cannot go back in time. He went from 100 seconds to 90 seconds. Okay. Time has to move forward. He has to either slow down or increase the speed. Okay. Okay. Which section shows a constant speed? Obviously, it's B. There is constant
B.
speed of 10 meter per second. Deceleration. Deceleration means speed is
C.
decreasing. C. Yeah. Deceleration is negative gradient. Okay. Negative gradient is always like that, and positive gradient is like this is positive gradient is a negative gradient. Section A shows acceleration of. Can you guys please find the acceleration of A part?
Is it 0.3?
Rise over run 10 divided by 3, 30 is 0.3. Okay. 0.3333. Okay. At least give two decimal place, that's better. The distance travel in the first 30 seconds. Can we find that? Obviously, that is going to be the area of this triangle. Half times base is 30, height is 10. Okay. 150 meter.